So I'm experimenting with this live thing, and I wanted to see how it worked. You're going to hear kids yelling and screaming in the background. I apologize. They're not behaving. So I'm going to do the best I can to get this working. For some reason, we're having focusing problems on the papers. So I'm going to zoom way in and try to do some basic ones, okay? So let's start here at the very beginning. I'm zoomed in. I apologize. It's kind of grainy. I don't know why it's appearing that way. I have no idea, but I will do the best I can with it, okay? So if you have questions, over on the right-hand side, it says chat. You can ask me questions on the live stream chat. And if you have questions about particular ones on this homework, or the midpoint and distance homework, I do have both of those here with me so I can do some. I am going to do a couple of these examples for you before I do that, and then see if that helps you guys out, okay? So on the first one, I'm going to actually do number 1 first. So number 1, we're talking about the angle addition postulate. Now if you remember, the angle addition postulate states basically that I have a pen that's not working. No, it doesn't say that. That would be too easy for my pens to actually work tonight. Anyway, so if I've got an angle, ABC, and I have a point D that's in the interior of that angle, and I make adjacent angles by drawing a line, the angle addition postulate tells me that the measure of this angle plus the measure of this angle equals the measure of the entire angle. That's what the angle addition postulate is. It's the same thing as the segment addition postulate, but you're using angles. The two smaller ones basically add up to the larger one, or however many angles, adjacent ones you have stuck together. Okay, so the first one says the measure of KLM. What is the measure of KLM? That's this one in blue. That's KLM. What is the measure of KLM if KLB is this one, KLB. If the measure of KLB is 26 degrees, I'm going to put 26 right there, and the measure of BLM is 60. So if the measure of BLM is 60 degrees. So basically it's asking you, what's the measure of the big guy, knowing the measurements of the two smaller ones. So I've got 26 and 60, so 60 plus 26 gives me 86 degrees. So the measure of angle KLM, which is the big one, is equal to 86 degrees. And that's a simple application of the angle addition postulate. That's on the front of your assignment. Most of you seem to do okay on this part. You have more trouble with the back. So I'm going to go ahead and switch to the back now and maybe do a couple of questions on the back. Let me pick one here. I'll actually look at number 16. So we'll look at number 16. And again, I apologize that the video is so grainy. This is the first time I've really experimented with this live stuff, and it does not apparently want me to be able to focus. So anyway, I don't know if it has to do with the bandwidth and the streaming, but let's look at number 16. So if I'm looking at number 16 says find X. So we're looking for X. If the measure of angle LMN is 135, so LMN is this angle, and the measure of that angle is 135 degrees. So I'm going to write it on the outside, because if I write it on the inside, it's going to overlap the other angles, and I want to be able to label my picture the best I can. So I have 135 degrees, and that's LMN. Now I've got LMV. LMV. That's LMV. LMV is -1 plus 45x. So I'm going to label that -1 plus 45x. After I do that, I'm going to move on, and now I'm going to look at the next angle, VMN. VMN is 23x. So now I've got my big angle, and I've got my two smaller ones. And so the angle addition postulate says, if you've got a bunch of angles connected, a bunch of adjacent angles, the sum of all of the smaller angles is going to equal the value of the bigger angle. So when I set this up, I'm going to basically have -1 plus 45x, which is my LMV, this one here, plus 23x, which is this guy here, okay? And that is going to equal 135 degrees, because 135 degrees is the entire angle. Oh, we got some viewers now. So 135 degrees, what's up, guys? 135 degrees is what the total angle is going to be. So I'm going to add the two smaller ones together. So it then becomes a matter of algebra, which is like terms. Like terms. So I've got 45x and 23x. I'm going to combine those guys. So 45 and 23 is 68. So I've got 68x. Then I've got minus 1 that's left all by itself equals 135. This is number 16 on the back of your homework that's due tomorrow. So those of you that just joined us and don't want to know what's going on, besides me fighting with my camera. Again, I apologize for the focus. I don't know why it's like this. Maybe it has to do with the live feed. So I'm going to come over here. I'm going to move that 1 over. I'm going to add 1 to both sides. So now I've got 68x equals 136. So again, I added the two smaller angles together and equal the bigger angle. So now I'm going to divide both sides by 68. And when I do that, I get that x is 2. Now, all this asks me to find is x. So I'm done. I don't have to find it. If it asked me actually to go back and find the other angles, I would basically take the 2 and I would plug it in for x. So for LMV, I would plug in -1 plus 45 times 2. And for VMN, it would be 23 times 2. Now, it's a good thing to actually plug these in, because then you can see if you got the right answer. You know your two angles are supposed to add to 135. So if you want to check it, well, let's check it, because we like to do things that way. The first one was -1 plus 45x. But what am I plugging in for x? 2. So for the first one, LMV, -1 plus 45x, 45 times 2 is 90. So -1 plus 90 is 89 degrees. So according to this angle right here is 89 degrees. So when I plug 2 into the other angle, I should get two angles that actually add up to 135 degrees. So I'm going to take this 2 right here, and now I'm going to plug it into this angle, 23x. Well, what's 23 times 2? That's 46 degrees. So that means this guy right here, this angle, is 46 degrees. So if you want to see if you got the right answer, what should those angles have added up to? 135. Well, if you check it, 89 plus 46 gives you exactly 135 degrees. So you know you've done this question correctly. Okay? What's up, Alejandro? Yes, you're going to pass. So I am probably going to do one more of these, because this is the one that a lot of you tended to struggle on. I had a lot of questions on these tonight. So let's move on down to, let's see if I can find a really nasty one. Well, they're all kind of nasty. Let's look at 17. I think I have a lot of people that had questions about 17, because I think we ended up having multiple algebraic representations here. What's up, guys? So I appreciate y'all tuning in. My kids are not screaming anymore, so we don't have any entertainment in the background. I apologize. So hopefully you have your assignment. If you don't, I apologize again for the focus. I can't fix it. I don't know what's wrong with it. I guess it's just not focused enough. I don't have any really witty, funny, stupid things to say. So on this one, I've got the measure of HIW, okay? HIW is this angle right here. Remember, you go from 1, the vertex is always the center letter, HIW. This is the one that we want to find, the purple one, okay? That's the one we want to find, the purple one. So knowing that we're looking for HIW, that's the measure. By the way, that's how you write the measure, that little M. If I'm looking for HIW, what I want to do is label the ones that I have. So HIJ is 145. HIJ is this guy, HIJ. Okay, that's the big angle. So this guy is 145 degrees. That's the entire angle, okay? Wij is this one. That's 10x, okay? 10x is Wij. Wij is this guy right here. That is 10x, okay? So the question is, we've got a big angle, and we've got one of the smaller ones, and we're still given one more piece of information we can plug in. So I know that HIW, which is this guy right here, HIW is 2x plus 13. Now I'm ready to set this up. So when I set this up, I've got the two smaller ones should add up to the bigger ones. So 10x, which is this one, plus 2x plus 13, which is that one, okay, is going to equal 145, which is that one. So hopefully that makes sense. When I get done with this one, guys, if y'all have any particular questions on any of these, you can ask me on this particular assignment. I also have the midpoint and distance assignment pulled out if you guys want to ask me any questions on that one. That's the orange packet. That's the orange paper that's due tomorrow. So now that I've got these set up, I'm going to go through and just do my algebra. So I'm going to combine like terms. I got 10x and 2x, that's 12x, plus 13, because that doesn't have any buddies, equals 145. Okay. So now what I want to do is I actually want to subtract. So I want to solve for x. So I'm going to subtract 13 from both sides. So that leaves me with 12x equals 132. Again, all I did was add. Okay, all I did was add. And then I moved, then I subtracted the 13 over. Now I'm dividing both sides by 12. And I get x equals 11. Okay, now in this particular example, unlike 16, which just wants you to find x, you are actually being asked to find HIW. Now don't be a smart butt and put a little arrow there and say, oh, it's right there. So we want to find HIW. HIW is this guy, the 2x plus 13. Well, I know x is 11 now, so I can just plug that in. So I'm going to do 2 times 11, because that's what I have for x, plus 13. And that's going to give me 22 plus 13, which is 35. So that is my answer, 35. That's the measure of angle HIW. Okay. Number 18, Alberto, I can do that. All right. So hopefully that made sense on number 17. Okay, I will do number 18 now. I'm going to move over to number 18. I might end up going to a pen or a pencil here because the pages are so small so y'all can see this a little bit better. Yeah, I'm going to use a pen here. So I'll do number 18. Okay, on number 18, ABC is 17x plus 8. So this whole angle right here is 17x plus 8. Hopefully you can see that, okay? So that whole angle is 17x plus 8. All right, so I just marked that one. Now, ABK is 42. ABK is this angle, and I'll use a little bit of color so you can see it here. ABK is that angle right there. That's the green one, okay? The measure of ABK is 42 degrees. Then we have KBC. KBC is this guy right here. It's the blue one, okay? The measure of KBC is 12x minus 4. Okay. So the question is, how do I set this up? Well, using their, no, this paper and the orange paper are the only things that are due. If you finish the one that you're working on in class today, if you didn't finish it, if you can turn it in tomorrow. I probably will take those till Monday on the parallel and perpendicular. Okay. So, yeah, the one we're working on right now is due tomorrow. Yes. So let me go ahead and add these together. So this one, the orange paper, and then if you didn't do the parallel perpendicular one. But I'm going to do some examples of parallel and perpendicular here in a minute. And I'm going to get, if you have the orange paper and you have any questions, ask me that because I've got the orange paper here too. So 12x minus 4, which is the blue angle, plus 42, which is the green angle, is equal to 17x plus 8. Okay. This was the paper that we got on Monday. This is the one that we got on Monday. I had passed it out with, and then you worked on it on Tuesday when I was out. It's on Google Classroom. You can either print it from there, and the key is there too, or if you can't print it, if you have a separate piece of paper and you want to do it on a separate piece of paper, you can do that. You should get through it pretty quick. The front side is really quick. So I've got 12x minus 4 plus 42 equals 17x plus 8. And I think where a lot of people got stuck on this is that you have x's on both sides. Well, let's combine like terms. I've got negative 4 and 42. And so that's positive 38. Because I basically have 42 minus 4. Okay. And then I've got 17x plus 8 on the other side. Now, if you remember from algebra, you can subtract these from either side. You need to move the variables on one side and the numbers on the other. So I'm going to move the 12x over to the 17x. So since it's a positive 12x, I'm going to subtract it. And that leaves me with 38 on this side and 5x plus 8 on this side. Okay, hopefully that makes sense. Okay. And now I want to move the 8 back over. So I'm going to move the 8 minus 8 to the other side. And that leaves me with 30 equals 5x. So basically this is just all the algebra. I think a lot of people got hung up on having the x's on both sides of the equation. Then when I divide by 5, 30 divided by 5 is 6. So x is equal to 6. But what the question is actually saying is to say, what is the measure of ABC? Well, ABC is this, right? 17x plus 8. So I know x already. X is 6. So I'm going to take that 6 and I'm going to plug it into 17x plus 8. So I'm going to do 17 times, instead of x, I'm going to plug in 6 plus 8. And that's going to be 6 times 17 is 102, plus 8 is 110. So that is the measure of angle ABC. So hopefully that makes sense and that helps out. Okay. Do y'all have any other questions on this paper? Those of you that are watching. Ooh, we're up to 10. I feel important. I will not be giving autographs away tomorrow, by the way. I think everybody's pretty good on this one. Do you guys have any questions on the midpoint distance, the orange one? I've got the orange one. I think I printed both papers. Well, it printed one page anyway. But I've got them all pulled up so I can print them. Okay. If you don't have any questions on that, I am going to review real quick the different types of angles. If you want to watch that. If you're good with it, you don't have to stay hanging out. But I'm going to go over complementary, supplementary, adjacent, some things I might ask tomorrow. Let me print one more copy of this midpoint distance, just in case anybody has, because I ended up with, somehow I just ended up with the second page. So you're going to hear my printer running in the background. Okay. Tomorrow for calculators, I'll work on the back as soon as I print it. Tomorrow for calculators, I will allow you to use the calculators. I generally will allow you to use calculators on quizzes. Quizzes and tests, yes. Regular work, no. But on the quiz and the test, I don't want you to miss it because of mathematical errors. So, is this what you're talking about, Alberto, on the back? This one here? The distance between these points, or do you need the one with the graphs? Let's see here. I think I can do this. I'm still figuring out this camera thing, guys, so. Okay, cool. All right, so I'll go ahead and do number 7. This is the one where we did the distance formula. So find the distance between each pair of points. If you remember, the distance formula was that nice ugly thing. The d equals the square root of x2 minus x1 squared plus y2 minus y1 squared. Okay, that's the distance formula. Okay, so, uh-oh, I have a little one coming. Hang on. Yes, sir?
Look how heavy my snuggie tail is.
Your snuggie tail, you got all your animals in there. Can you come say hi, everybody? Come here. Come here. Sorry, that's what happens when you have a 5-year-old. Can you say hi, and then Mommy needs to get back to work. Just say hi. Just say hi. Say hi.
Say hi to who?
Everybody, say they're watching. Say hi. I'm Kaden.
Hi, I'm Kaden.
Okay, take your snuggie tail now. Go in there. Go see if Daddy can get you in bed. All right, so that's the distance formula. What we're going to do is use the distance formula to find the distance between these 2 points for each of these. So what I'm going to do with each of these is I'm going to identify which one is x1 and which one is x2. So for each set of points that you have for the distance formula, you're going to have an x1, y1, and an x2, y2. Those are just some arbitrary points that you're going to plug in whenever you're trying to find the distance. Thank you. Yes, he's pretty adorable. I like him a little bit. So these are your 2 points. He's actually hanging out right outside the door right now. I've got x1, y1, and x2, y2. Okay, and I'll do some midpoint too. I'll do some midpoint too. So when we do the distance formula, what I'm going to look at is I'm going to plug in these 2 points to this distance formula. I don't know if you remember in class, we kind of talked about how this comes from the Pythagorean theorem. That's why it's the square root. I know. Go. Daddy, a little assistance, please. Don't y'all enjoy live videos? I do. So let's get going since it's taken us 5 minutes to do this question. All right, I'm going to rewrite the distance formula. And remember, I told you when you rewrite formulas, rewrite them without the values plugged in. Without the values plugged in, okay? So what I'm going to do is I'm going to rewrite the formula so I don't get the negatives mixed up. Now I'm going to go back and look at what my x's and my y's are. And I'll try to use some color on this one. My markers are a little bit thick, which it was kind of bleeding through the paper. All right, what are my 2 x coordinates? Okay, 7 and 0, right? So I'm going to plug 7 and 0 in for my 2 x coordinates. Now I'm going to look at my 2 y coordinates. So my 2 y coordinates are 6 and 2. So I'm going to plug in 6 and 2. So now I'm actually ready to solve my distance formula. And you can plug this into the calculator, and I will allow you to use calculators tomorrow. But when you plug it into the calculator, you have to put an extra set of parentheses around it, because otherwise the calculator reads left to right. And when it goes left to right, what it's going to do is it's going to take the square root of this and then drop the square root and then add whatever this is on, which will give you the wrong answer. So let's just keep going and keep the square root sign. We'll pretend like we don't have a calculator. 7 minus 0 is 7, so that's going to be 7 squared. Everybody agrees on that. And 6 minus 2 is 4, so that's 4 squared. Again, all I did was I took my 2 x's and 2 y's and plugged them into the formula. Okay, so now 7 squared is 49. And remember, whatever numbers you get here, when you square things, they always become positive, so be careful with that. Yes, so you'll put brackets. You can put brackets, Alberto, or you can put parentheses. You can just do a double parentheses. So if you wanted to make them brackets, you could make them brackets. That would work too, okay? So I've got 49 plus 16, and 49 plus 16 is 65, so your distance is the square root of 65. You will have a calculator so that you can actually calculate this. And if you do the square root of 65, it's like 8.01 or something like that. And so that would be your distance, okay? I am going to do one more distance one because I want you guys to be careful with the negatives, okay? So I'll either do number 9 or number 10. Let me do number 9 because we've got negatives in both of those, okay? So I'm going to move up to number 9. Let me kind of watch here and make sure that I'm in the right screen. Okay, so here's number 9. Let me make sure I've got this angled right. You know me, I'm OCD. So again, our distance formula, whenever it asks for distance or length, we are looking for the distance formula. So the square root of x2 minus x1 squared plus y2 minus y1 squared. Now, little secret, I'll do one with the graphs, just a sec. I am going to give you the formula tomorrow, so you guys don't have to memorize this, okay? And then I'll do one after this, I'll do one on the graph, and then I'll do a midpoint one so that we can get the midpoint, okay? So I'm gonna rewrite my formula again. It looks like you guys are getting the hang of this. Again, with the negatives. And the reason I do that is for a problem like this one. What are my 2 x coordinates? Well, my x's are -6 and -3. Now look what happens. I'm going to have a negative. I'm going to have a negative. That's why I always have you write that original symbol in with the formula, because a lot of people will get confused and just do, oh, -6 minus 3. That negative is its own negative, and that subtraction sign is its own subtraction sign. So we've got 2 different things here that we're dealing with. So now let's go to the y values. The y's are 1 and 1. Okay, so that one's going to give you something easy. I was going to try to show you how to do this on the calculator, but unfortunately I think my calculator has dead batteries. Well, we might be able to do it. Let's see if I can get a calculator in the screen, guys. How about that? And I'll show you how to do this one on the calculator, okay? Because you'll have calculators tomorrow. All right, so can you guys see that with the calculator? So get it in the screen there. We scoot it over a little bit. Okay, so on the calculator, this is what you're going to do, all right? You're going to enter the square root sign, okay? So, okay, good. So you're going to enter the square root sign. All right. There's one parentheses that automatically pops up when you put the square root in. But remember, that parentheses is this one. So you either have to put another one or change it to a bracket. The easiest thing is to just put another one. So I'm going to put another parentheses in. So that should pop up. Okay. So now I've got a double parentheses. Now I'm going to look back here. I have -6. Okay. And remember, negative, I'm going to slide this up for a minute. This is the negative button. This is the negative button. The negative button right here and the subtraction button right here are different. If you put negative in when you're trying to do subtraction, the calculator will give you an error. So when you have a negative number, you put the negative one. And when you're doing subtraction, you put the subtraction symbol that's up here, okay? All right, so let's come back down here. All right, so I've got my double parentheses. So I've got -6 minus -3. Then I'm going to close my parentheses. And then I'm going to hit the squared key. Now here's the squared key right here. X squared. You just hit it. And that squares it. Okay? Once you've done that, now let's move over on the formula. Plus, parentheses, 1 minus 1, close parentheses, squared. You hit the x squared button. Okay? But remember, we added an extra parentheses at the beginning, right? So that double parentheses we have in the beginning, I have to close it now. So I'm going to close it, and I'm going to hit enter, and there's your answer, 3. So it's 3. Okay. I'm just going to hit a button on the back of my phone here to start charging it. So hold on a second. Okay. So I've got 3. All right. They're playing with some toy now. I don't know why they're not in bed, but that's okay. All right, let me do one with a graph, and then we got midpoint, because I know we got someone waiting on midpoint. I will get to it. I promise I'll get to it. Okay, So hopefully that helps you out with the distance and how to enter it in the calculator. You can see specifically there, you've got a double set of parentheses in the front, and then after the last squared term, you put parentheses. Now, I am going to let you have a calculator on the test tomorrow, and I am going to give you the distance formula. Sorry, quiz. I don't want to scare you too much. Okay, let's do one with a graph, and then let's do some midpoints. All right, let's do number 12. Okay, so number 12 is going to be the same thing as what we just did, except you've got to do one extra step. You actually have to locate the points. Up here on these, like on number 10, the points were given to you. Hi, guys. The points were given to you. On 12, the points are not given to you, so the only difference between 10 and 12 is that you actually have to find the points. So I look over here and I just do graphing. So this point right here is at 1, 2, 3, 4, 5 for X. And then it's at 1, 2, 3, 4, -4 for Y. So there's the 1 point. And now let's get this point. So this point is at -1, 2, 3, 4, 5 for X, -5 for X, and 1, +2 for Y. So the only difference between this one and the other two that we just did is that I had to actually find the points first. Now you do the same thing. You've got your distance formula, and I'm going to write it again so you can see it again. Even though I'm going to give it to you tomorrow, you guys that have been watching are probably going to have it memorized. Okay? So the distance is going to equal, I'm going to rewrite my formula. My two X coordinates are -5 and 5, so I have -5 minus 5. And my two Y coordinates are 2 and -4. Okay, 2 and -4. So with that being said, I've got everything set up for distance. Now I'll show you how to do it in the calculator again. Let's put our big brackets around it and let's get back in the calculator. I'll show you how to do it in the calculator because we've already done one without it. So I'm going to hit the square root button. And then I'm going to add a double parentheses, remember, for the calculator. And then negative, remember, negative is this button. I'm going to hit -5 minus 5. Remember, you got to be real particular with what buttons you're using, okay? I'm going to close it. I'm going to hit the X squared button, okay? And so that's the first part, plus 2, and we've got minus a -4, which is the same as +4, but this is what you would do on a calculator. Minus -4. Okay, so I've got minus -4. Close it, square it. Remember, close the parentheses just like we did up here. And 11.7 is your answer. And that's number 12. Does that make sense? Hopefully I need to do a midpoint one. I know we've got someone waiting on midpoint. We good? Okay. All right, so let's do one with midpoint. I just printed that page. Okay, so I'll do a couple on midpoint. There's several on midpoint. The main one is going to be, you're welcome. And I'm going to be on for a little bit longer, so if y'all have any other questions, just let me know, okay? So, you're welcome. You're very welcome. So, let's look at the midpoint, because a lot of you guys were having trouble with midpoint at first. Remember, you can use the midpoint formula. Again, I'm so sorry about the focus. I keep apologizing for that, but you guys know me. I'm OCD. Everything has to be perfect or I go nuts. So on the midpoint, you can use the midpoint formula, and here's the midpoint formula, and I'm probably going to give it to you tomorrow as well, just because I'm that kind of person. But basically the midpoint, remember, is just the average of the sets of coordinates. It's just the average of the sets of coordinates. So on the midpoint, let me get my pin here. I threw it somewhere. I was throwing a lot of things earlier, but y'all just can't see it because it's off camera. Not that that's important. So what I want to do for midpoint is I'm going to do the same thing I did for distance, all right? I've got my formula. I'm going to set it up, and then I'm going to plug in my values. So basically what the midpoint is the average of the x's and the average of the y's. So the two x coordinates that you have -4 and +3, right? So the midpoint is going to be the average between those two. Like if you had the example I think I used in class, if you had a 90 and a 100, your average is 95. And the reason your average is 95 is because you did 90 plus 100 divided by 2. So that's what we're going to do. You just do them with each set. So I've got -4 and 3. Those are my two x coordinates. And remember, it's addition. Don't get this confused with slope. And then I'm going to do my two y coordinates, which are -2 and 3. So now I'm ready to set these up and do my midpoint formula. So -4 plus 3 is -1. So that's going to be -1/2. Okay? -2 plus 3 is 1. So that's going to be 1/2. And there's your midpoint. So if I were to put these 2 points on a graph, that's exactly where the halfway point would be. At x, remember we kind of called it xm, ym. That's the midpoint between the two if I were to graph it. Okay? So that's how you find the midpoint. Now I'm going to do one where you're given the midpoint and an end point, and you have to find the other end point. Okay? So let's move on here. And this is the one where we did what we call the stack in class. And after this, guys, I'm going to probably do some fractional distance because I know some people had questions on fractional distance. I'm going to try to print that paper out and do some of those. If you need to take a break and come back, I'm going to go until my battery runs out on my phone, which hopefully is not too terribly soon. I'm working on getting that plugged in. I have a charging case, but I don't know if it's charging very well. All right, so let's see here. I'm talking to myself. Let's find the extra coordinate here. All right, if the end point is at -5, 4, so we're going to imagine this segment and this midpoint in the middle. The midpoint is at -10, -6, and the end point over here is at -5, 4. Okay? So what I want to do is I want to find the other end point. So in order to find the other end point, I have to figure out, well, how did I jump from here to here? And so I can stack these or I can go left to right. It's really a preference for you guys. So I'm going to do the stack first. I know I started at -5, 4. Then I jumped down to -10, -6. So the question is, where's this guy? Well, you have to watch a pattern. You know that it's exactly in the middle, right? Okay. So how did I get from -5 to -10? Well, to get from -5 to -10, I actually got 5 less, right? I'm trying to move this ever so slightly without messing up the camera. Oh, there we go. Boom. I subtracted 5 because I moved from -5 to -10. I went to the left 5. So in order to stay exactly in the middle, I have to go 5 more in that same direction. So my next point is going to be at -15. Again, the difference in this one and then the first one we did is the first one gave you the 2 endpoints and asked you to find the average or the middle. This one is giving you one endpoint, the middle point, and asking you to find the other one. So that's the x value is -15. So let's find the other one. So on the other side, I've got +4 to -6. Well, what did I do here? To go from +4 to -6, I moved 10 units down. Okay, remember these are your y coordinates, up and down. Does everybody see that? I went 10 units down. So I've got to go 10 units down again to stay even and keep this point in the middle. So my point is going to be at -16. So this is going to be at -15, -16. Now some of you were doing your standards retest today and I could tell how you were doing it. So you went from -5 to -10 and you showed me, oh, that's -5. And then you said, oh, from 4 to 6 is -10. And you did it that way and then showed me you did the same thing the other way. That'll work too. Okay. Does that help y'all with the midpoint? Are we good on midpoint? I wanted to do a little bit of the fractional distance. Let me see if I can find that one. Let me know if y'all have any other questions or if there's anything you're confused on. I'm pulling up the fractional distance worksheet right now. And I'm going to print it because a lot of people had issues with that. And I wanted to make sure that, oh, I got a kid banging on the wall over there. Woohoo! Okay, good. I'm glad that helped with the midpoint. Okay, so let's see here. All right, let me find it real quick. Give me just one moment, please. I got to find it and print it. And I think I've got it. We did it last week, and so I saved it. Let's see here. I'm looking. Let's see here. All right. Hold on, guys. If you have a specific one that you want done, oh, you know what? I have one. Hold on a second. Let me go grab the worksheet. I'll be right back. Don't go anywhere. Okay, guys, I'm back, and I've got a fractional distance worksheet. So if any of you guys have any specific questions on any of the fractional distance worksheets, let me know. I'm going to adjust this just a little bit to see if I can plug my phone in. It's running a little low on battery, and I don't want this to kind of wig out on me, so hang tight just a second. If I can get this plugged in and somehow keep this from falling over, we will be in great shape. Okay, so I'm going to get a blank paper, and if you guys have any questions on fractional distance, you're welcome. If y'all have any questions on the fractional distance worksheet, let me know. I can do a couple of those. The fractional distance worksheet is this one. So if y'all have any questions on these, hold on a second. There we go. This is the fractional distance one. Had all these on there, had the little squares. If you guys have any questions on those, I'll do a couple of them. I'm going to do number 1. Okay, so I'm trying to do this here. Okay, so let's look here. Fractional distance. All right, so I'm going to do this the best I can. I can't. Okay, you're stuck on that. Okay. Is there, let's see here. Let me do a couple of these. So that might help y'all out a little bit. And my pen ran away. Oh, there it is. I found it. It was trying to hide from me. Okay, so on the fractional distance paper, let's do number 1. It says, and I can't move it over any further, unfortunately, because of just the way the camera's oriented. So this is the best I can do. It says segment AF is graphed so that A is located at -2, 5. So what I'm going to do first is I'm going to just draw a random segment. Okay, and I'm going to call it AF because that's what they call it, right? Okay, and let me move my paper over a little bit, and I'll draw where you can see it. So A is located at -2, -5. and F is located at 3, 5. Okay. So the question is, we want to find point P. We want to know point P. Point P, and that probably is not a good representation, is 1/5 of the distance from A to F. So we want to know how do I find 1/5 of the distance? Well, first of all, we've got to figure out how far apart each set of coordinates is. So you're going to do a distance for the x's, and you're going to do a distance for the y's. So let's find out how far apart the two x coordinates are. If you remember, when we do distance between 2 points, it's the absolute value of the difference. So this one is at -2, and this one is at 3. That gives you -5, which means these points are actually for the x's, and I'll label this is the x values. The x's are 5 points apart. So does that make sense? If I go from -2 to 3, that's a distance of 5, okay? So now let's do the y's, and let's see how far apart the y's are. Well, the y's are -5 to 5, okay? So for the y's, I'm going to do the same thing. If you want to know how far apart two things are, it's the absolute value of the difference. So for the y's, I've got -5, that's a horrible 5, and +5. So -5 minus 5 is -10, okay? And the absolute value is 10. So what we just figured out was that the two x coordinates are a total of 5 units apart, and the two y coordinates are a total of 10 units apart, okay? So now I don't want to go that full distance of 5, and I don't want to go that full distance of 10. I only want to go 1/5. 1/5 only. So I'm going to take 1/5 of each distance. 1/5 of the y and 1/5 of the x. So I'm going to take this 5 and I'm going to take 1/5 of it. That's the same as multiplying by 5 over 1. That gives me 5 over 5, which is actually 1. Okay? Then I'm going to come over to the 10, the y distance, and I'm going to take 1/5 of that as well. So 10 divided by 5 is 2. Okay? So what I'm doing now is I'm not going to go from -2 to 3, 5 full units. I don't want to go 5 full units. I only want to go 1/5 of that. What is 1/5 of 5 units? 1 unit. So, point P, what's -2 plus 1? If I only move 1 instead of 5, where do I end up? -1. For the y values, -5 to +5, I don't want to move the full 10 from -5 to +5. I only want to move 2. So I'm going to add 2 to -5 instead of 10. And that puts me at -3. So this point right here is 1/5 of the distance from A to F. Once again, you find out how far apart the original x's are. We got 5. It's the absolute value of the difference. You find out how far apart the y's are. That was 10. That was the absolute value of the difference. And then you multiply that by your fraction, because I don't want to move the full 5 units from here to here. I only want to go 1/5 of the way. So 1/5 of 5 is only 1 unit. So instead of adding 5 to -2, I'm only going to add 1 to negative 2, which puts me at negative 1. Okay? And then, same thing here. I'm not going to move 10 from negative 5 to 5. I'm only going to move 2. Okay? So that is how you do the fractional distance. Okay? Some of the questions on that one are also, those questions on that one are also midpoint, so make sure you just look carefully. Number 9 was a bonus. I'm not even going to put that in your brain right now because I don't want you to get confused. So don't worry about number 9 on this paper. I think I told you all that before you turn it in. So anyway, that's how you do the fractional distance. So that should help you on how to do the rest of them on here. I'm looking at, if you do, one that a lot of people were confused on was this one right here. And that one was actually pretty simple. You're only doing it once instead of twice. So on number 3, I guess this one would be, it says on a number line, which number is 7/9 of the way from negative 6 to 3? Well, on a regular old number line from negative 6 to 3, you wanted to see what was 7/9 of the way. I wanted to go 7/9 of the way. So to go 7/9 of the way, I had to figure out how far apart they were first. So how far apart are negative 6 and 3? Well, you do the same thing. You take the absolute value of the difference between the two, and you end up getting negative 9, which is 9 units. And we're taking, what, 7/9? So these guys are 7/9 apart. I want that is 7/9 of the way. I don't want to go 9/9, right? That's the whole thing. I only want to go 7/9. So I'm going to multiply 7 over 9 times 9. Just like on the other one we multiplied by 1/5. 7/9 times 9. Those actually cancel. That gives you 7. So I only want to go 7 units. So negative 6 plus 7 puts you at 1. And that's how you do the fractional distance. Okay. So I'm going to do a couple of things on angles that might be on the quiz tomorrow. Hint, hint. Just so I can give you some examples. So on the quiz tomorrow, remember, you're going to have the different types of angles. And you're going to have to know the different types of angles. So bear with me here. All right, the types of angles that you're going to need to know. Let me move this over a little bit. Right here. Adjacent. Okay, adjacent angles. Adjacent angles are angles that share a side and a vertex. Oh, when you get a chance, can you do number 11 on the orange packet? Yes, let me do some angles and then I'll come right back to that one. Okay, so I've got adjacent angles. Adjacent angles, remember, share a side, a vertex, and no common interior points. Okay, I'm writing it all out for you. So remember, when you have adjacent angles, that's going to be basically, you've got 2 angles and they share a side and a vertex and they don't overlap. So to kind of color code that for you, pretend like this is one of the angles, Mr. Purple, and this is one of the angles, pink. Whoops. That's a horrible picture, isn't it? That is awful. So that is 2 ugly adjacent angles. Okay. That's what adjacent is. Now, why these are adjacent, there is no point in the pink angle that is also in the blue angle. Remember, they cannot overlap. They cannot overlap. So they share a side and a vertex. So if I name these angles P, Q, R, S, because I'm really original, right? Angle PQR and angle RQS would be your adjacents. What do they both share? RQ. And what vertex do they both have? Q. Okay. So that's adjacent. Let's do complementary. real quick. Let me do these real quick and then I'll get to the other number 11. So then we've got complementary angles. Okay, complementary angles. Remember, complementary angles, that's a pair whose sum is 90. 90 degrees, okay? So these two angles, 50 and 40, those are complementary. Remember, you can take the complementary, you can change that to a 9. Those are complementary. What do two adjacent complementary angles make? A right angle. Okay, all right. Okay. So let's look at the next one. That's complementary, supplementary. We got supplementary angles. If complementary adds to 90, supplementary adds to 180. So we've got supplementary angles. And supplementary would look something like this. This is 65 degrees and this one is 115, something like that. They add to 180, okay? Now, if I actually make the supplementary angles adjacent, for example, if my 115 is here and my 65 is here, what do we call those? That is actually a linear, okay, because it's two adjacent supplementary angles. All right, so we got adjacent, complementary, and supplementary. And we got two more angle types, then I'm gonna do number 11. Okay, so we've also got, or actually we got one more angle type because we've got the linear pair. The linear pair, I'll kind of just write it on its own. The linear pair, remember, it's a pair that makes a straight line. Any straight line is 180 degrees. So a linear pair, 110 degrees, 70 degrees. That's a linear pair. Linear pair, remember, are adjacent and they're supplementary. They share a side and a vertex and they add to 180, okay? Next one, the last one that you need to know are the verticals, okay? So you've got the vertical angles. And remember, vertical angles are always congruent, okay? They are always congruent. Remember, I told you I'm going to give you that picture with a bunch of lines, okay? In this picture here, and I'm going to actually use letters just to make things interesting. In this picture, okay, you've got ABC. Angle ABC is this guy right here. Y'all see that? Angle ABC is vertical with angle DBF. Okay? Since those two are vertical, what else can you say about them? They're congruent, right? Okay, they're congruent. So now let's look at the other pair of vertical angles we have. I have ABD, which is this guy, is vertical to CBF, which is this guy. So those guys are vertical. And you know that the vertical angles are always congruent. So for example, if this one is 50, that's CBF. This one's also 50 because the verticals are always the same. Always. Now beyond the vertical angles, I also have some linear pairs here. Do y'all see the straight lines? Okay. If I were to cover this up, you see the straight line there? So if that's 50, what do straight lines add up to? 180, that's a linear pair. That has to be 130. Since these are vertical, this one's 130. So the verticals are congruent and all of the straight lines add up to 180. Do you see the 180 there? The 180 there? The 180 here? And the 180 there. Okay, so those are the different types of angle pairs that you're going to have. Let me do number 11 on the orange packet. Okay, number 11 on the orange packet. That would be this one, I believe. Uh-oh, let me get this. I can't get it to all show here. There we go. Okay, that's number 11 right there in case you can't see it because my camera's a little wonky. All right, so number 11, I got to look for my 2 points. So that's 5, -1, right? And this one over here is at -1, 1, 2, 3, 4, +4. So I've got those 2 points, and now I want to find out the distance, which is also the length of this thing. So I'm going to use the distance formula. So the distance formula is the distance equals the square root of, remember, x2 minus x1 squared plus y2 minus y1 squared. Okay? So I'm going to come back and I'm going to do the same thing. I'm going to rewrite my formula without anything plugged in. Excuse me. And then I'm going to go back and check. So let's look at our x values. -1 and 5 are our 2 x's. Okay, -1 and 5. So I'm going to plug in -1 and 5. My 2 y values are 4 and -1. So I've got 4 and -1. So I've got my 2 points. I've got them plugged into my distance formula. And then from here, you can go to the calculator. I'm going to actually come around here and just kind of extend it a little bit and work it out the long way. So -1 minus 5 is -6. And remember to keep the parentheses, -6 squared. Plus 4 minus -1, which is 5 squared. When I square these, -6 times -6 is +36. When you square a negative number, it becomes positive. So plus 5 squared, which is 25. So the distance is equal to 61, the square root of 61. Now, the square root of 61, you would probably need your calculator for. I know I'm the smartest person in the world and I can't do it in my head, so not really. 7.8. So your distance is about 7.8. So hopefully that helped on number 11. Okay. And you do the same thing for 13 and 14. Okay. Do you guys have any particular questions on any stuff that you don't understand? Fractional distance, midpoint, distance, the different types of angles. Parallel and perpendicular, I might put one question on there tomorrow, but it'll be easy. It'll be an equation type thing. It'll be something like this. It'll say y equals 4x minus 7 and y equals -4 1/4 x plus 2. Are these lines parallel? Oh yeah, I figured that would have been what happened on yours because you were probably looking at getting the -1 and the -1, and that would end up giving you 0, which is possible. It's possible. But yeah. Well, I'm glad you caught that. So I've got 4 and -1/4. Remember, your slope is what's in front of the x. So I may ask you, what kind of lines are these? And what would you tell me? They're perpendicular. Okay. So I've got 4 and -1/4. So these lines are perpendicular because they've got opposite reciprocal slopes. Remember, perpendicular, if one, like you have +4/1, its perpendicular is going to be -1/4, and so on. Okay. What if I gave you these two lines? What would you tell me about those two lines? Those are parallel. And how do I know they're parallel? It's because they both have the same slope. Both of them have a slope of +3. So these guys are parallel because they have the same slope. Okay, same slope. And then what if I gave you something like this? Those guys are neither. They're not parallel because they're not the same, and they're not perpendicular because they're not opposite reciprocals. Okay. The last thing I'm going to show you is what you may have tomorrow is you may have a situation like this where I give you 4x minus 3y equals negative 16. That's standard form. And I may have you rearrange that into slope-intercept form. Now remember, slope-intercept form is y equals mx plus b. So if I have standard and I want to get it in slope-intercept, and I'll use colors here, I want to get the y all by itself and isolate the y. So first thing I'm going to do is I'm going to move that 4x, and since it's a positive 4x, I'm going to do negative to move it over. That'll cancel that. The negative comes down, negative 3y stays negative, equals, and I cannot combine negative 16 and negative 4x, okay? So I'm just going to leave it negative 4x and negative 16. I can't put those together. They're not like terms. Like I said in class, you can't have 5 apples and 10 oranges and get 15 apples. It doesn't work. You can't do it that way. If you figure out how to do that, let me know, because my kids love apples and oranges. All right, so what I'm going to do next is I'm going to get a 1 in front of that y, and the only way to do that is to divide by negative 3. But remember, I have to do the same thing to every term in the equation, every single one. So negative 3, that ends up being y. And then negative 4 over negative 3 gives you positive 4/3 x, because negative over a negative. And negative 16 over negative 3 gives you positive 16 over 3. And you can't really reduce those. They're ugly numbers. So you may see one of those. But the rest of them will be fractional distance, angle types, that kind of thing. So do you guys have any other questions before I go reintroduce myself to my family? I hope this helped. I know we had quite a few people watch, which was really cool. So those that didn't watch or weren't able to watch, hopefully they'll come back and be able to help out. I know I've been on here for about an hour now, so I hope this helped you guys out. And just make sure you study. I've got to go fix up the quiz. So we'll do that tomorrow. And you guys let me know if you have any other questions. Just hit me up. All right. Appreciate you guys watching all this fun stuff. And we'll see you tomorrow.